from my side, ladies and gentlemen, to this future lecture. I am very glad to meet all of you here in person, and we have also quite a number of the visitors who are online with us, so good evening to everybody. And I'm very happy to welcome you now to our future lecture. And as you know, we have different topics, which are all emerging topics in science and technology. And today we have a very special one with the name World Avatar, Buildings of Resilient Cities. And maybe there are a lot of people who have seen the movie of Avatar, so I am very much looking forward how that correlates. Just to remind you that our future lecture series is always related to our different research fields, and this lecture today is closely connected to chemical engineering, and also thanks to our Professor Heinrich, our colleague who has helped to organize that. And I also welcome here our president and vice president for teaching, Professor Kersten. And we have today also one very special guest from Politecnico di Milano, the vice president of Politecnico di Milano, Professor Guadagnini. He's here also visiting us. So I think we have today a very prominent consortium, and I would like to introduce our speaker today, Professor Markus Kraft. This is a great pleasure and great honor for me to have such a speaker here. Professor Kraft is a leading figure in the field of data-driven modeling, machine learning, and semantic web technologies. He is a professor in the Department of Chemical Engineering and Biotechnology at the University of Cambridge and a fellow of a Churchill College. And he was also now for several years in Singapore and is a founding director of the Cambridge Center for Advanced Research and Education in Singapore. So since early 2025, he decided to change the continent, obviously, and he is now a guest professor at MIT for 1 year, and then obviously he will be back to Cambridge to his research and teaching. His outstanding achievements were recognized by his election as a fellow of the Royal Academy of Engineering, and one of his most significant projects is the World Avatar, which is a revolutionary initiative that uses dynamic knowledge graphs to create digital replica of our world, actually, from a molecular level, what chemical engineering always does, but now to entire city, which connects us to the civil engineers, and I'm glad to see several colleagues from civil engineering also here. So we will hear today how to integrate the data from different sectors and how to develop long-term resilience strategies against also the climate change, which brings me to the motto of our strategic initiative, also engineering to face climate change. And after the talk of Professor Kraft, we will have also a small demonstration of what we have here in Hamburg related to this research. For sure, this is our machine learning and engineering initiative, which will be very shortly presented and also presented outside for the poster session, and our graduate school also for the future of the cities, which is our common graduate school with the Hafen City University, which is also presented outside by the poster, and I thank the colleague coming here and contributed to this evening. So I think this is a very interesting hour we have in front of us, and afterwards, if everything goes well, we will have beer and brezel outside together with the poster session. And now I'm very much looking forward for your lecture, Professor Kraft. Please come to the stage, and we are really looking forward to learn what is World Avatar for you.
Thank you very much. Thank you very much. Before I start, I'd like to say thank you very much for inviting me and giving me the opportunity to visit Hamburg. It's always nice. Next time I come in summer. So let me just start with the title, and you've been mentioning the World Avatar. So what does that actually mean? Of course, here the world is not planet Earth. the world is the space of all concepts. And hopefully in the course of the lecture that'll make a little bit more sense. Before I start, I give you some context, and I know Hamburg knows everything about extreme weather events. I mean, like, I'm old enough to remember that Hamburg had extreme weather events in the past, but it's not just Hamburg. As you know, I'm from the University of Cambridge, and Norfolk, which is just in the northeast of Cambridge, also is very flat and gets flooded, and of course is subject to the effects of bad extreme weather events. And let me just show you a little video to give some context.
Extreme weather events caused by climate change are on the rise. When we're not prepared for these events, the consequences are more serious. Failures occur across interconnected infrastructure networks, meaning power cuts, loss of communication services, and running water. This can severely impact people's everyday lives. And this is only going to become more of a problem in the future as these events become more common and more extreme. Ensuring that infrastructure is resilient to these events is critical.
The climate change resilience of infrastructure networks is a challenge that is not yet well understood and is one we need to address urgently. Asset owners really need to know who are they dependent on. It's really crucial both for the integrity of the assets but also for the service you provide your customers. For example, a range of infrastructure providers. If one of them is affected, let's say, by flooding, and that maybe affects an electricity substation, and then that problem cascades to perhaps the water company that's using that electricity to run its plant and pump water, or perhaps the communications infrastructure that needs that electricity to run the communications network. Understanding these risks in advance and how we can mitigate them is key.
So this gives the context of the problem, and one of the key problems here is interoperability. That means we have different systems that are sort of disconnected, but in order to understand the full picture, it's important that we connect them together. So the question, of course, is how do we do this? Okay, so I'm sure I've been here now for 2 days, and I've heard the word digital twins many times. So I'm sure everybody in some way or another has heard about digital twins. And in order to solve the interoperability problem, digitalization may provide the key to it. So do the current digital twins already fit the bill? That's the question. And what I'd like to do now is to shortly explain how we see the evolution of digital twins and what needs to be the case in order to solve the interoperability problem. So I'm sure I have here a little graphic, and as you can see to the left, there's sort of the pre-digital twin era where we just have data and models, and most of these models were ad hoc. They were inconsistent because researcher A used parameter B and researcher X used parameter Y in order to model one and the same thing. And so this was also a manual process, and very often in a silo. So chemical engineers do chemical engineering, civil engineers do civil engineering. They don't talk to one another. So how do we get away from it? Of course, now digitalization makes things different. So the next step is then digital twin. You have a mathematical model that is connected to some device. That device can in turn inform the model, maybe just parameter estimation, maybe control. And so as these digital twins emerge, you can then start connecting these twins, and the moment you connect these twins, you will see that certain standards in community A do not overlap with standards in community B, so there is no common way of interacting, so you have a naming problem. And that eventually leads to what we call ontology-based digital twins, is sort of a Lego wrapper around a digital twin that allows the communication between two digital twins. But these digital twins, they are dynamic because the world is dynamic. Just like I change my position on this stage, like this, things change in a digital twin. So that needs to be also part of, and for us, the processes that make these changes are called agents, and they in turn are part of the ontological description, and that gives you full provenance, leading to a full systematic picture of the world that's consistent, automatic, and connects everything. And that is what you end up in the world avatar. Now that sounds crazy, but of course, if you really think about it, there's a whole lot of world avatars just looking at me, because each of you have a world model. And this world model consists of concepts. If I ask you, describe what you see, you will say, aha, here's a stage, there's a human on the stage speaking, and then if I walk around, you can give a position information to me, and that means in your brain there must be an agent that constantly reflects the changing world, okay? And if you want to have a full, consistent picture of the world, then that is what you have to have. So the next thing is, we are now in a process where really revolutionary things happen. And I think I would like to explain this, because the ultimate consequence of such a model, such a world avatar, is this change in perspective. And we already see this to some extent. So this is pre-digitalization world. So there is a why and a how, and there is a human, and there is some sort of machine. So now the way I explain it normally is to say, so imagine this is my mum, okay? So, and my mum has a goal, and this is why she does things. This is the why. She does something to do to fulfill a goal. And my mum's goal is to make me happy, okay? So then the next thing comes. She needs to know what needs to be done to make me happy. For that, you need a knowledge representation, a knowledge model of the world. Okay, so my mum knows, okay, I need to bake a cake to make my son happy. Okay, so then the knowledge representation breaks down this goal and say, how do I do a cake? Okay, I need some ingredients, I need to go to the supermarket, I need to put them together, I need to use this machine, the kitchen mixer and the oven, and then she operates all of these things, and this is the how, each individual step, so goal to sub-goal breakdown, and the actual performance of the individual steps. And that, of course, also requires that she is able to acknowledge each change in her environment. So anyway, the cake comes out, and in fact, on Friday, I will eat it, okay? So it's already in the planning. But now, we are moving to a different world. So far, the knowledge about the goal and how to reach there and what needs to be done was all in my mom's head. Okay? Now imagine, this is not me, okay? This is not my mom, this is me. And my goal is, of course, make my wife happy, okay? And how do I do it? By baking a cake. Now, the problem between me and my mom is that my knowledge model doesn't have this information, okay? So I need to get this information from somewhere else. Now, the first revolution was when humans started writing things down. So where we basically represented knowledge models outside our head. The first step, we were writing things down. The second step was the printing press. Now it was much easier to distribute information. Okay? And I was discouraged to take my mobile phone with me onto the stage. But at this stage, I would hold it up and say, here in my mobile phone, there's a lot of information. So I could, of course, go and find a cooking book, cake making book in my home. I don't have one, okay, to get the knowledge model that is needed. But of course, nowadays, I just can take my mobile phone out, do a bit of Googling, and I get the recipe. Then I need to know where to get the ingredients. I can just Google it and it tells me where to go. Okay? So far, the recipient of this information was a human. I was able to interpret this language with my knowledge model in my head because I can handle this language. So of course, if you want to then fully automate it, you need to be able to teach machines how to communicate, right? And this is what the semantic model, the world avatar, is all about. Okay? So now here we have the why. A machine doesn't know the why. The why needs to come from outside. And then you have the world avatar. And in the world avatar, you have the knowledge model that tells you the how. And that instructs not just machines, it also instructs humans. And if you use Facebook or social media, you're already instructed, not necessarily consciously, but you choose your actions because you have an interaction with your mobile phone, because you are influenced by the information you get. You don't choose necessarily what information you get. Maybe an algorithm chooses that for you. So we are not a million miles away from that situation already, right? Now imagine we now want the same system also for machines. So not just for humans, but also for machines, all in one system, okay? So what do you need to have? You need to have a methodology that derives goals from the goals to the individual sub-goals. And what you also need to have, you need to, this forms a network. The way we do the knowledge representation, we use semantic web. You need a methodology that traverses the change of the world through that network, through the representation of the world and the way the knowledge is representation. And we do that by employing the derived information framework, or that is in development. So what I'm showing you now is not a solution of everything, it's just first steps into this direction. And we have already demonstrated that we can do this on a country level, on a region level, district level, city level, building levels, down to the molecular, down to the quantum chemistry. Because I told you earlier, the world avatar lives in the set of all concepts, even the concepts that haven't been invented yet. So we are not restricted by any topic, by any use case. They are intrinsically already included. So let me just give you a few examples. So this was a study where we looked at the consequences of implementing heat pumps across England and what effect that has on fuel poverty. And for that, we needed to have fuel poverty data in the first instance, the peak power consumption of households, and climate data, because a heat pump efficiency depends on the temperature. I mean, thermodynamics, I'm sure some of you have already been tortured with it. Okay, so then I will talk about this in more detail. This is about networks. Then during COVID, there was 2020, I traveled home to Germany to see my mother, her 80th birthday, and then I wanted to get on a plane back to Singapore, and then all planes were cancelled for the next 6 months. So I spent 4 months at home in Pirmasens. I'm not sure whether anybody knows where Pirmasens is. I'll give you a hint. It's Normally, if somebody asks me what is Pirmasens, where is it? I said, it's in the most beautiful part of Germany. And then people say Bavaria and so on. So it's been Saarbrücken and Karlsruhe, 80 kilometers north of Strasbourg. It's a beautiful area. If you want to eat and drink, good place to go. Anyway, so I'm digressing, I suppose. Yeah. So anyway, I was then in Pirmasens, and then I thought, okay, we do smart cities in Singapore. Why don't I talk to the mayor in Pirmasens? And then I talked to the guy who runs the Stadtwerke, and then they have a district heating system. And this is also sort of an interoperability problem because it depends on school holidays, on the consumption, on the electricity prices. So in there, they have a local power plant, there is a municipal waste plant. So in that power plant are different boilers, there's also a gas turbine. So the question is, should I run the boiler or should I use the gas turbine? The gas turbine needs an extra person to be operated on, and so on. It's a very complex problem. And so we use sort of world avatar approach to develop basically instantiation of this. Then we've also worked for Singapore. I'll talk about this later. We also represent buildings, both in terms of building information model, but also building management systems. And we have automated our laboratory. And we've also been using it, as I said, for molecular representation. Here we have a very simple automated potential energy surface finder. We have explored the space of metal organic polyhedrals as a chemical and used that to find new molecules, including synthesis recipe, and also developed a natural language interface. And this is what I want to talk about quickly, because everybody knows about large language models, and hopefully, I guess, just like me, I'm using it every day to check my English and my German. And but you can now ask all sorts of questions. However, under some circumstances, these models still hallucinate. So they give you most probable answer and not the right answer. And of course, especially as an engineer, you want to have the right answer. And if you work with as a head of Stadtwerke, you cannot have the most probable answer. You need to have the right answer. So the question is, how do you combine a large language models, say, with the facts? Because you can't always retrain the language model. It's far too expensive, out of reach. So what you do is what's called RAG systems, and maybe some of you know more about this than I do. So it's retrieval augmentation generation models that connect machine learning and the data that comes in. And we have done this for the built environment. And this is Zaha. Maybe the architects or civil engineers may know of Zaha Hadid. He's a wonderful architect, unfortunately dead by now. So this is not hallucinating. And here you'll see a few questions. And the interesting bit here is that it combines GIS data, geographic information systems. There's basically two-dimensional mapping data. It combines live time series, and it combines regulations. And of course, for a civil engineer or an architect, it is not only a question, what is the soil structure in a specific land lot, but also if I want to build a house, do I fulfill the building regulation? How far away is the road for me to choose the right architecture and the planning? So, so that's Zaha. And okay, I must not be too long. Okay, so that was a rough idea about the world avatar. What's behind it? What do we want to achieve? And I've promised to talk about the effects of extreme weather events, and that is what I'm trying to do now. So what we've been working on is an automated flood impact assessment. And we want to understand the potential on people and on buildings. And what you see here is a 2D representation. I mean, architects or civil engineers will recognize this as Mapbox, which is for us an output agent that shows some aspects of the underlying knowledge graph representation. And what you see here is there's a flood warning, a flood alert, and then we ought, because we have now information, a representation of everything that's there, we can now tell you, okay, the effective number of buildings is 920, 3,475 people, according to last census, are currently affected by this, okay? So you get up-to-date insights of what's going on. So if this flood alert goes up to a flood warning, then you see, okay, the property price effect has suddenly changed. So for the UK, we have included all sensors that are publicly available. So we can assess weather, water levels, rainfall, air quality, in principle any sensor that is basically on the internet. So I just show a few examples. So here these are the weather station and air quality stations. Then you have here water levels. You can then see air temperature in a specific place. This is the King's Lynn Youth Hostel. And here, this is air monitoring, nitrogen oxides in King's Lynn roadside. So now imagine these sensors are in Hamburg. So you basically have a system where you have automatic access to this. And this is not just made for humans. This is just the output so that I can talk about it. The whole point about this system is that the machines can investigate this, that there is a language that is general enough to immediately access all these points. So now a bit further in, so here these are water levels at a certain station up here, and we see that it's over time it's rising. Then we can go downstream to the next water sensor, and you get the information here, so you know how far this flood wave is progressing along your river, and you get some sort of information, or at least a time that is that you have to do some countermeasures. So of course, these were just the sensor data, but of course you have important networks. And so we've been working with Anglian Water, British Telecom, and the British Power Systems. So each of these companies have spent thousands and thousands of pounds to push their digitalization efforts. So they have a very good representation. They have a whole operational, it looks like Starship Enterprise when you go to their offices, okay? But of course, they have no idea what the telecom network looks like or what the power network looks like. So the idea is then, how can we connect these networks and how can we operate on it? So let me just go through this example. So imagine for a moment you have a power station, a substation, secondary substation, and these two pumps and these phone masts are connected to it. So suddenly you're in a situation where this doesn't work any longer. So you wonder, so what's going on? So, okay, it has lost its power, but you see it's not flooded. So what's going on? So we can then investigate, there is a primary substation that is flooded, and we can identify another substation that can mitigate the situation here, right? And so this is work that was done in the framework of the National Digital Twin program in the UK, and there is a Guido climate resilience demonstrator, so you can check this out. And of course, there's also a question of rescue. So say, imagine you want to go from A to B, and there is classical routing. To do that, there are algorithms that, I mean, I'm sure you've all used navigation algorithms, Google Maps and so on. That's the same thing, to go from here to there. But then, of course, in case of a flood, you may not be able to do this. So what do you do instead? Okay, so because the system understands where the flood is and the impact, it can then find a fast route for the ride and can choose the right vehicle. So for example, you can have, that's called context-aware routing. So imagine you have an ambulance with a wading depth of 10 centimeters or 20. Yeah? Then the way to go from here to there is all that. If you have a fire truck, wading depth half a meter, still the same way. So you need to know amphibious vehicle to go there directly. And so now this is just an example of a dynamic choice of actions that is important in this case in the context of this flooding. But you can, of course, then also go further on and can have disaster planning. And again, for civil engineers or architects, city planners, they would have they would have something like this. These things are called isochrones. So this is the time you need to get to a certain place. So if you live within that dark red area, that means within 2 minutes you will be to the hospital. If you need in this area, it'll be 4, 6, and so on, right? Now imagine the moment you have a flood, this changes. Suddenly the isochrones look completely different. And in fact, you suddenly end up with 4,300 people who cannot enjoy access to a hospital. So that means, as a city planner, you better put something up there in order to mitigate this effect that you don't have access, okay? So, but you cannot just look at whole regions, you could look at specific, at the whole traffic network, and that's what we've done here. Again, we've identified critical infrastructure by just basically also a mathematical algorithm that allows us to go from any point to any other point, and then you can identify these two bridges and see that they play an important role. And then based on that, you can then choose, okay, which of these bridges is the best one to repair, and that allows you sort of post-disaster recovery to make sure what action should I take in order to get back to normal in the fastest way. So the final example, this is about sea level rise. And as you know, there's global warming. This is not an invention. It actually takes place. And as a consequence, we will expect the rise of sea level quite substantially. And some of you may know the IPCC projections. So they basically claim that up to the say the end of this century, we may face substantial sea level rises up to 2 meters, in some areas even more. So what does that mean for a country like Singapore? So you see basically two pictures here. Now, the first one, okay, here, yeah, you see that we've been using the NASA elevation model. That was before we made friends with the Climate Center research for Singapore. And these guys, of course, they have access to the to data that is of national interest, that is not public, and you can see that the quality of data makes a big difference. And especially, and that also sends a message, because you may argue, well, Avatar is all good, but if it is, not everything is publicly available. So one of the problems we've been solving was how to hide certain aspects to certain parties. I'm not talking about this aspect here, but I just want to make you aware that we are also aware of this problem. So back to this analysis. So what we've been doing here was just using a bathtub model, and that means that we've just increased the water height at a water level and didn't take any other physical phenomena into account. So we then looked at how is the population affected by the sea level rise, we looked at the buildings, and here you see that we have various building usages that we analyzed. And without going into detail, the key point here is that you have the property usage, but also the construction costs, and this is vital information for insurances. So, so this is, of course, this increases the probability of being flooded in the first place, which in turn determines the property value. And if you look at the construction cost for a single building, then you can see that we're talking about billions of worth that may be at risk due to just rise of seawater. Finally, I was a bit too early with the finally, but we're getting there. But this is the finally, so don't worry. And that brings me back to the mobile phone. So if I had my mobile phone, I would pull it out again. Now imagine, maybe this is interesting for Hamburg as well, because Singapore has a harbor. It's one of the biggest ports in the world. There's a lot of ships in Singapore. And these ships burn not very clean fuel. So as a consequence, you get the black dots is a live position of ships, okay? And so what we've been doing, depending on whether they are stationary or moving, because you can get this information, you can estimate the emissions of these ships. And the dark area shows you where we have made this estimation. Now imagine your mobile phone tracks your position, your movement. What it doesn't track at the moment, it doesn't tell you what's the environmental impact because you're walking through an area that is affected by ship emissions, like particles, NOx, and so on, right? So what we've done is we've built a soft sensor that basically tells you, based on the location of your phone and your speed, how much you are affected by these ship emissions. And that is what you see here. This is the PM10 along this trajectory. So the idea is that you then get an individual footprint of your NOx exposure as you walk away. And this is NUS. We were just talking about it earlier. You walk from NUS to Sentosa, Vivo City. And for people who've been to Singapore, they would know what I'm talking about. And then you get your specific individual pollution footprint. And from that is only a small step to then correlate this with health records. And that is exactly what we are doing in Singapore. There's a thing, it's called Trust Platform, where they try to standardize health records. So the idea is that we, on the one hand, look at the environmental exposure of people, their activity levels and their health records, and see what influences what for a specific, in this case, Asian population. But you can then derive all sorts of quantities. Here we talk about average exposure, and from that we can then move on and see, you know, is it important? Is it the maximum of the exposure important, or is it the average exposure, the important quantity, and so on? And that's what we're trying to investigate in this project. So we are getting to the end, okay? In conclusion, what I really try to get across is that the world avatar, this concept, semantically links and acts on any physical and digital components, linking all presented use cases to just one system. Everything I've shown is just one system. It's not disconnected. Every sensor, every agent in Britain can find out what's going on in Singapore. So that's the idea. And with that, I would like to thank you for your attention, and if you have questions, I'm happy to answer.
We have now just a very, very short 3 slides presentation of what we are doing actually in Hamburg University of Technology in the area connected to that. And Professor Schulte will present this.
Thanks a lot, Irina. What I want to present to you is the Machine Learning in Engineering Research Initiative at TU Hamburg, where at these points of time we've got around about 90 members, ranging really from PhD students to full professors who, thanks a lot, who contribute or who do research in the field of machine learning at our university, and not only at TUHH, but also at some further organizations like DESI and Herion. So why does this research initiative actually exist? Because a lot of us from all different areas which are research topics here at TUHH these days are doing some way or the other machine learning research. This goes from really the mathematical foundations of machine learning research to really the conceptual approaches working on the next generation of lightweight, energy efficient, basic machine learning algorithms, of course, up to the application of these algorithms and of existing algorithms in new areas. And the research which we are doing in MLE is now divided into certain different fields. I've already talked about the mathematical and conceptual foundations. Apart from that, you can see that here we've got 3 different pillars. Namely, pillar 1, there's a modeling technology which, for instance, we already heard the term today, builds and uses digital twins as faithful representations of the real world, and researchers are here working on integrating ML models and machine learning algorithms, also training into these digital twins. In pillar 2, controlling technology, for instance, researchers are working on cyber physical systems, which, as we know, are a very big topic here at TUHH. We know cyber physical systems have actors and sensors and interact and monitor the real world. And the question here researchers are working on at TUHH or within MLE is how can we integrate, let's say, machine learning models as first-class citizens into these cyber physical systems. And in pillar 3, analyzing technology, we are actually investigating, for instance, how can we, let's say, use machine learning algorithms to evaluate the use of technical systems in the real world. For instance, this evaluation of how we can do that ranges from, let's say, anomalies in products to classify them, to predictive maintenance, and even some people are working on the impact of technology on the human society. So, and last but not least, we are also interacting with industrial partners in MLE. So from time to time, there are also meetings with industrial partners, of course, in order to find out if we can collaborate in projects or in some other way. So if you now think MLE sounds very interesting, then I want to highlight that on 1st of April, we've got the MLE Day 2025, which is open, of course, to all the members of the MLE initiative, and everybody else can, of course, join as well. So we are very open to actually find new members, and whoever is interested, please join us on April 1st from 9 in the morning. Location here at TUHH in Building H. Yeah, and if you want to participate, please register so that we've got enough cake and coffee for everyone. So please send a mail as indicated here on this slide. And yeah, we are still in the process of updating the MLE homepage, but there will soon be information about how to register also on the homepage. So this said, yeah, if you're interested in MLE, we will have at the get-together some posters, so just some example posters of what some of the researchers in MLE are doing, so you can talk to the researchers who are presenting their posters there. I will also be around, yeah, so if you have any questions about MLE, just contact us and we will be happy to answer your questions. Thanks a lot.